Hello, welcome back to my channel. In this video, we're going to be naming alkanes. The first one would be to name this compound. Okay, so in naming alkanes, the first thing we need to do is to identify the root. And the rule is that the root would be the longest carbon chain. So if we are to count, if we count from this other side, this is 1, 2, and 3. You're counting the carbons, right? If you count from here, it gives you 3. Now, what if we count from the other side? We count 1, 2, 3, 4. This is 4 and 5, right? So you see that this other side gave us 5 and this side gave us 3. So the longest chain is the 5, and that will be the root. And anytime you hear 5 in organic chemistry, when you are naming, 5 is represented by pent. Now this pent is the prefix. We've gotten the prefix. Now we're going to go get the suffix, right? Now the suffix is going to be telling us if this is an alkane, or alkyne, or cyclic or aromatic. Now, looking at this is not in a ring form, so we're not going to be thinking that this is cyclic. So it's left between alkane, alkane, and alkyne. And looking at it, because there is no double bond or triple bond, we know it is alkane. So since it's alkane we're dealing with, the suffix will then be "ane." Now we have our roots. The next thing we need to identify are branches. Are there branches on this carbon? Now let's find out. So if we're dealing with this part, we have 1 identified, we have the 2, and we have this. It means that this part that wasn't counted with the parent is the attached compound or the attached group. So, and it is a CH3. Now let's note that when you see an alkane, okay, that is missing 1 hydrogen, it's called, say, minus 1 hydrogen. It's called an alkyl group. So this CH3 here is a methane, which is supposed to be CH4, that has lost 1 hydrogen, and it will be called a methyl group. Okay. Now, when you go to the 2 carbon alkenes, which is an ethane in this case, when it loses 1 hydrogen, it will be called ethyl group. Okay, so you'll be meeting a lot of this as we go along naming. If it is 3, it has lost 1 hydrogen, or it becomes an attached group, it will be called propyl, and so on. So in this case, now we have a methyl group attached. So a methyl group is attached on the 2nd carbon. So you have to now then say 2-methyl pentane. So this is how you name this compound. Okay, so another thing I would like to point out is that numbering is very important, and which side you number from is also quite important. Now, if you number from this side, it gives a lower priority of number to this attached group, right? And that is the proper way of numbering. Now, if we had numbered from here, there's 1, 2, 3, 4, and 5, it would have given the attached group a higher number compared to when we go this way. So in chemistry or in organic chemistry, when you are naming, you have to assign the lower number to the attached group. So you count in a way that you assign the lower number to the attached group. Okay, so let's go to the second example. As usual, we'll find the parent, okay? And the first thing we have to consider is the prefix. So we have the 1, 2, 3, 4, 5, 6. We have 6. Let's check the other way. We have 1, 2, 3. It is lesser, so it can be the parent. We have 1, 2, 3, 4. Also lesser than this other part. So our parent will be 1, 2, 3, 4, 5, 6. And 6 is represented by hairs. Okay, so we have hairs, and of course this is also an alkane. We're dealing with alkanes, so it will be hexane, right? Now we have our parent carbon here. The next thing we need to consider is the attached groups. We have two attached group here. We have this is a methyl group, and this has two carbons, so this is ethyl. And the ethyl group and the methyl group are all in the same carbon. And remember what I said about assigning numbers, right? You cannot assign from this side, because if you count from here, it's going to give this 5, whereas if you count from this other end, it's going to give it 2. So we go with the 2. So this would be a 2 ethyl 2 methyl hexane. Okay, now note that we actually follow it alphabetically, right? So you see that here you have the ethyl group coming first, because E comes first before M. Okay, so that is it for this second example. The third example will be a line structure. So let's name this compound. Now in line structures, note that each of these sides represents a carbon. Okay, we can count. So this would be a 1, 2, 3, 4, 5, 6. This is a 7 here, 8, and 9. Okay, so we have 9, and 9 is known. And of course, we are dealing with alkane, that would be nonane. So we found our parent carbon. The next thing we have to then do is to look at the attached groups. So is this numbering correct? No, it is not. So that's another thing we need to consider, is that at this end, we are going to give 7 to this, which is wrong in naming. So we have to renumber what we had. So normally, you see that at the point of trying to find your longest chain, you might not actually consider that. But at the point where you then have to start attaching your groups, your attached groups, always remember to assign a lower number. So at that point, you renumber them. So let's renumber this. So if we renumber it, it's going to give us, here will be 1, and here will be 2, and here will then be 3, right? So in that case, you have your attachment at the third carbon. Unlike when we went this way, we had it at the 7th carbon. So it shows us that this side is a better numbering than this other side. So at the third carbon, you have ethyl group and a methyl group attached. Now let me explain. Where you have a stroke as an attachment, just this stroke you're seeing here, any of them is called a methyl group. Okay, and when it is two of them joined together, it could come out in this form or in that other form or any direction, but once it's two of them, two strokes, is called ethyl group. And then when it is 3 of them, it's called a propyl group. And it could be any of these two. It could be from any direction, okay? But once you can find 3 strokes coming out from that main carbon, okay, as an attachment, it's called a propyl group, okay? So at this point, you see that at 3, you have 1 methyl group and then another 1 ethyl group. So in them in alphabetical order, the ethyl group will come first. So you have 3 ethyl, 3 methyl nonene. If I'm to write it out better, 3 ethyl, 3 methyl nonene. And this will be the name of the compound. Thank you for watching. Please like, comment, and subscribe if you found this video helpful.